live right now. Good morning or afternoon, depending on what part of the country you're in today. And welcome to today's webinar, Technology Solutions for E-Recycling Accountability. My name is George Burgos, and I'll be handling the technical aspects of today's webinar and will be advancing the slides. While we wait for the others to log on, I would like to cover a few housekeeping items. By now, you should have the GoToWebinar application running and should see the welcome presentation on your screen. If you're having technical difficulties using GoToWebinar, you can go to www.gotowebinar.com and click on the frequently asked questions in the blue navigation bar on the left side of the page. For those of you joining us via phone, there may be a short delay of the seminar visuals. Presenters will pause briefly between slides to compensate for the delay. Note, a copy of the slides can be found in your chat box. We encourage you to ask questions. Please use the GoToWebinar control panel and type your questions in this area that says questions. Click send to submit. Please type your questions throughout the presentation. With that, I will now turn it over to Lauren Roman.
Good morning, everybody, and thank you so much for joining today's webinar. We've been challenged for so many years in the electronics recycling industry, and technology is advancing at such a fast pace that I thought that this was a really good time to bring together stakeholders from the government, from the electronics recycling community, and from the automatic identification and data capture community, so that we can talk about what opportunities we have to help solve these problems and let technology help us do the work. So my name is Lauren Roman. My company is TransparentPlanet, and I'll begin today by quickly going over the mechanics of the meeting and introducing our speakers. So first, the meeting mechanics. Next slide. So our first four speakers will frame the issues, and our last two will discuss possible technology solutions. The panelists will engage in live question and answer. So after each person speaks, if there's any time left, the panelists will ask questions, and if there's any additional time, we'll take questions from the audience. But for the most part, I have a feeling we'll probably wind up taking most questions at the end. As Jorge said, participants may submit your questions at any time by typing into the chat box, and we'll get to as many questions as possible. Any questions that we can't answer today will be individually responded to after the meeting, and a recording of the webinar will be available on both the TransparentPlanet and the US EPA websites. So I'd like to introduce myself, give you a little bit of a background on me. So I established TransparentPlanet in 2008 to explore technology solutions for tracking products and materials through the life cycle. Many of you are familiar with my work in electronics recycling, and now I work with organizations of all types to help identify the best tracking solutions for managing assets, ensuring sustainable supply chains, and supporting product stewardship. I've worked really closely with the EPA on electronics recycling issues since like the mid-90s, and I'm really keenly interested in the commitments that the federal government has made under the National Strategy for Electronics Stewardship, also referred to as NSES. So I convene this meeting to help all stakeholders understand some of the capabilities of automatic identification and data capture technology and how it can help governments, electronics OEMs, and electronics recyclers have improved accountability in the full life cycle of electronics. So I'll give you a little overview of our speakers, and you'll learn more as they each go through their presentation. So our speakers today include Karen Pollard, who's worked on electronics recycling issues for the US EPA for many years. We have Sally Demise, who is on the team with EPA's Office of Research and Development, working on NSES goals. Beth Johnson is with Dell, and she is responsible for Dell's US Producer Responsibility programs. Kelly Keogh of Green Eye Partners, whose company has the daunting task of auditing electronics recyclers to the two industry standards, and who understands better than anybody how difficult it is to currently verify material flows from recycling operations. Chuck Evanhoe is the chairman of AIM Global, which is the leading industry association for automatic identification and data capture technologies. And we have Tom King, who's with the U.S. Patent and Trademark Office, which is currently implementing an RFID tracking system to track IT assets. Our panelists include Walter Alcorn from the Consumer Electronics Association. Walter works on and advises members regarding environmental issues around electronics, including end-of-life issues. Jim Puckett is from the Basel Action Network, which houses the eSteward standard for responsible recycling and reuse of electronic equipment. And finally, Steve Skurnak from Sims Recycling Solutions, which is one of the largest electronics recycling companies in the world. So I'd like to now turn our meeting over to Karen Pollard. Karen?
Hello, everyone. Okay. So thank you for that introduction, Lauren. I am Karen Pollard, and for those of you, I understand there's about 200 attendees on this call, so some of you probably don't know me. I am the team leader for the Sustainable Electronics team in the Office of Resource Conservation and Recovery. We are the EPA office that regulates hazardous waste, we regulate municipal waste, and we work on voluntary efforts as well. I've been involved in used electronics for almost 10 years. My specific roles have changed over the years. I've been involved in a lot of different things, but I tend to be, you usually hear my name when it deals with electronics work that has some sort of effect on the electronics reuse, recycling, scrap, or waste. Can you change it to slide 2? Thank you. Today I've been asked to set a stage for this discussion. I plan on talking about why the federal government is interested in tracking the flows of used electronics, what work we've already done, what work we are continuing to do. Slide 3, please. EPA is really glad to be part of this discussion. I want to give a big shout out to Lauren, as she's the driving force behind getting this much needed discussion started. While this discussion is not directly a part of the follow-up of EPA's 2014 Electronics Forum, it is certainly an important conversation we need to have, and so we're glad that she's been the push behind it. For those of you who have been in electronics world for the last while, you will know that we've had a number of staff changes over the time, but I want to take an opportunity just to introduce a few new employees here. We're really, really lucky to have hired a couple people, and 2 of those people are Brandon Bray and Leah Ioannis. Yeah. Brandon actually is on the electronics team. He and I work very closely together. He joined the team in September of last year as a physical scientist. He comes to us from McGill University, where he got a Master's of Science in Earth and Planetary Sciences. He also has a BA in Geology and History from Colgate University. A little bit of feedback. Somebody put their thing on mute. Thank you. Leah Ioannis recently joined the international team of our office. She has a master's in both public policy and conservation biology and sustainable development and the environment. And that's from the University of Maryland, and she holds a BA in biology from Wesleyan. She's worked, before she came to EPA, she's worked throughout Latin America in fields of conservation and international development. So we're real excited to have both of these folks joining us. I'd suggest you guys to put their names in your speed dial because I'm sure they'll be very important people to know and have a contact with in the very near future. And some of the other names you'll recognize, Rick Cardy and Stephanie Adrian, they are continue to work in the field of tracking electronics. So, and after my part of this talk, I will be introducing Sally Demenis, who Sally is with our Office of Research and Development, and he is actually currently working on a project in this area. All right, if you can move to the next slide, please. Okay, thank you. During the development of the NSES, we found that we had major information gaps in both the domestic and international flows of used electronics. We had an idea.
Karen, excuse me, Karen, you're breaking in and out. Can you speak directly to the mic? You're fading in and out.
Okay, but you also need to know that there is a lot of feedback on mine. So if somebody needs to be putting them on themselves on mute.
I already put them on you. I could hear you fine now. Thank you.
Okay, thank you. Sorry, something's kind of going on and off here. We had an idea, we had some information on what was actually being collected for recycling and reuse, but past that, it was a blank slate. We didn't have much information at all. This led to a number of the commitments that the federal government actually made, and those commitments are with regard to the federal electronics tracking domestic electronics, and what gets exported out of the United States. It's the specific commitments are here on this slide. If you can go to the next slide, please. Thank you. Most of the work that has been completed of these commitments is in the export area. Consequently, we still have a lot of gaps in the domestic flows of the used electronics. It's important for us to fill those gaps, and there's a lot of different reasons, and I've highlighted a number of them. But in general, the more we know about where these used electronics go, in what form, and how they are managed in the U.S. will help us verify many of the gaps that we currently have. And you can see I've kind of highlighted a number of different areas that knowing more information will help us verify information in these areas. Completed. The next slide, please. The next time we just want to touch on some of the completed work. We have been working, across the federal government, we've been working on different areas in tracking flows. I added this first RFID grant information, not because it was specific to tracking. It wasn't. It was broader than tracking, but there was some work done that talked to following the electronics through the recycling flow and providing more information to different recyclers as it went through. That grant was given. We learned a lot about RFIDs and electronics recycling, and so if that is some of the ideas that folks are thinking about as we move forward, they really should go back to that grant and find out where some of the issues were so that they can correct them before we go down that path again. Many of you know that we, the U.S. government, produced 2 reports on the international flows of used electronics. One was done through the International Trade Commission, and the other was done by MIT through EPA's funding. There's a little bit of information about those reports, but in general, I look at those reports as a baseline of what electronics might be exported. But another big thing that these reports did was they highlighted where there were a lot of gaps and places that need improvement as we go down the line of really understanding what these flows are all about. In bullet 3, you'll see that there were new reporting requirements by the GSA, specifically the federal reporting requirements. Since NSES was published, GSA has been providing more information in their annual reports on property provided to non-federal recipients, which would be recycling industry, when it refers to the transfer or disposal of used electronics. For example, agencies are now asked whether their electronics are going to a certified or a non-certified recycler. GSA continues to work to finalize a final rule, which will mandate the electronic stewardship guidance found in the FMR Bulletin B34, and it will include, this rule will include things such as using certified recyclers and more reporting requirements. And finally, EPA has revised the CRT rule, and that work was done in 2014, and we made those revisions specifically to help better track and use CRTs being exported for both reuse and for recycling. You could switch to the next slide, please. All right, our work in this arena is not complete, not by far. In addition to the two completed export reports, there's a third one, and that one is also on international flows, and it is being conducted by the CEC. The CEC is an international organization established by the United States, Canada, and Mexico under the North American Agreement on Environmental Cooperation. That report is part of a multi-phase effort to understand the quantities of used computers and monitors that are generated, collected, and exported within, between, and from Canada, Mexico, and the United States to the rest of the world. This report is in its final phase, and we are really hoping, fingers crossed, that early this year, so soon, hopefully, it will be released. And additionally, we're always looking to work with other federal agencies to find new ways to track the flows of exports of used electronics. Okay, finally, the next slide, please. So we are happy to be part of this discussion. It takes a whole bunch of us to answer these questions, and the federal government can't do it alone. We need each and every one of you to be part of the solution. And at this point, I need to turn it over to Sally. Thank you, and Sally, take it away.
Okay. This one. Oh shit. Sorry. Okay. Thank you, Karen. My name is Salih Minse. I'm with the U.S. EPA Office of Research and Development, and I thank you for this opportunity to share some of the work we do here in Cincinnati. I'm a member of the material flow analysis team, currently studying on the flow of used electronics in the U.S. My team members here with me are John Glasser, C.C. Lee, Suhail Alabed, and we have a new student, co-op student who recently joined us, joined this team, is Joshua Dietrich, and the team leader is Trey Richardson. Next slide, please. So as ORD, as part of this work is as part of the national strategy, as Karen mentioned, is ORD has previously worked, we worked on lifecycle assessment of rare earth element, collaboration with NIOSH on exposure of lead on recycling work sites, and also we made the effort in developing a sustainable electronic roadmap, and that is available actually online right now. So one of the barriers to encouraging sustainable electronic management is the absence of accurate information on material flows. So I post the supply chain in the industry and at the end of the service life. So the objective of this work is conducting a national study to assess the historic flow and current flow, and also maybe also to predict potential future quantities of electronic used electronic in different regions and across the state, and assess the different tracking methods and developing these information-based methods to estimate flows and make this information available to decision makers and to the public. Next slide, please. So, more specifically, the goal of our work is to assess the domestic flow and stocks of electronics and the effectiveness of the current legislation and the current management practices. And as Karen mentioned and Lauren mentioned, is that identify information gaps, identify what materials are available, what information is available, and what parts, which data can be estimated, and what is unavailable data. So develop a method that will enable us to use this and evaluate and compare the information related to best management practices for flow of used electronics. So next slide, please. So the approach we follow is that we select representative sampling.
Excuse me, Sally. This is Lauren. Can everybody please mute their phones? It's the microphone button to the right of the control panel. Thank you very much. Go ahead, Sally.
Okay, thank you, Lauren. So the approach we chose for this is that we select the representative sampling of states that will serve us as a proxy for assessing material flow assessment, and collect available information about the generation, recycling, export, recovery, reuse, and downstream flow of used electronics, and develop a model, a material flow model, and then identify data gap and assess environmental impacts and economic impacts of the various steps of this, from recycling to regeneration and also reuse of used electronics. Next slide, please. So, as you know, out of the task we were given was to look at the domestic movement of electronic waste. But although out of the 50 states, as you know, only half of the states have actually e-waste laws, and there are some aggregate data. Different websites are available on especially collection. However, the data is incomplete, and the data from states without codified laws is even more challenging to get. So we chose to use a cluster of Midwestern states for this study at the beginning of our work, and actually this study we started about about a year ago, about end of 2014. So in the first phase of this work, we are looking at selected states, what's typically called as Region 5. These states have very similar e-waste laws. First one was from Minnesota, and others, most of them emulate Minnesota's regulation, and the time frame also of the regulations came into practice are very similar. So we thought there is some homogeneity here and similarities between the states, and also how the laws came into practice, and we chose this for the first phase of our study. Now, one thing to point out is that Ohio doesn't have any codified state law. Next slide, please. So the goal of this is, what we chose to do is that we collect information of available information from state regulations and from recyclers and from our various sources, and review current available literature and that's relevant information, and then summarize this and develop a material flow analysis tool that will help us to condense the information and also assess what we are lacking, what we are missing. So, next slide, please. An example of the current states, for example, in Midwest, is that there is quite a, although we thought there is a lot of similarities, but there is also differences how the laws are implemented, both from manufacture, from registering, both collectors, recyclers, and this what we see is that this also somehow affect what kind of data and the quality of data and the detailed information that we get from the data. So this is an example of the 5 states that have codified laws. Next slide, please. And here what we see is that both the states reported collection and recycling in Midwestern states, and what we see is that the data varies by the state, and it's in some ways actually that we get a more detailed data on recycling materials than collection. So. So we see both how the laws are implemented and the data quality and the time frame of the data quality all differ. So we need to do a lot of data quality assessment and validation of what's reported. It's just to give you the kind of information we are collecting. Next slide, please. And another thing we are also looking at, in addition, is that more detailed studies of going deeper into an example here is the state of Wisconsin, is that various aspects of collection sites related to e-waste is collection sites, recycling sites, of registered sites, and so that to compare this with population distribution, the demographic the population distribution across the state, and as we find that in some counties, rural counties, some rural counties lack collection sites. So this may account into differences in the volume of collection per capita. Next slide, please. So basically, material flow analysis is an accounting and an analysis tool. It's based on a systems approach and material mass balance. So in this case, the system consists of a certain arbitrary boundary, for example, a state or a region, and it systematically connects the sources and pathways, accumulation or collection, storage points, and finally the sink. And it provides the state policymakers a decision-making tool to conduct scenario assessments, and also where does the material go, especially from the recycling downstream. So it tries to, the intent is to close the material balance and better to give a better picture of the flow of used electronics and the flow of materials. So. And helps to compare practice of different states. So next slide, please. And here is an example of the chart or the model that we are looking at. These are the system boundaries, inflows into this system, and also various streams. All of these have to be determined spatially and temporally, and also some have to be estimated. And as you see, that it's not an easy task. somehow, and the confidence we have in also in the different streams, different mass flows is also has to be looked at. So this is an example of the kind of picture we want to develop for different regions, especially at the state level. Next, please. So weight-based material flow analysis is a good starting point, but this does not tell us anything about the actual environmental impact. So the data has to be down later. Once we try to complete this picture, we have to link it with lifecycle assessment attempts to develop a common framework for environmental impact assessment. We need also to look at more critically look at the data. What does it mean from policy context, and also other and related economic effects of the material flow recycling. So all this has to be, once we try to complete the picture, we need to do more, link this as the material flow data with other evaluating techniques, life cycle assessment and economic assessment, to have a more complete picture of how the laws are implemented and what does the data tell us. Next, please. So our goal now this year in FY16 is to complete the Midwest region study, to conduct a detailed material flow analysis for selected states, and we have a draft report that will be completed by the end of this fiscal year, and provide recommendation for the coming years. So our goal is focus on Midwestern states and complete and show some with how material flow analysis models can be applied at this different using the data we get from different states. Now, one thing here, what you see is that next slide, please. Yeah. So one of our major challenge is data gap, and we are looking at various ways, and maybe even looking at expand the survey techniques to complete this data gap. And this actually, this current today's discussion is an excellent opportunity for us to seek for what other alternative sources are there to complete the data gap, and how. And in the future, this study is more likely to continue for the next few years within our Office of Research and Development, and so assess. So we will expand to other clusters or other areas in the U.S. and also link our results to other economic effects and how this can be applied at national level, because we need to have a better national strategy or master plan on how this is applicable to at a federal level. Thank you.
Thank you very much, Sally. What I'd like to do is, we have a few extra minutes because unfortunately Beth Johnson of Dell is not going to be able to join us this morning. I'm going to speak about Dell's program just for a few minutes before we go on to the next speaker. But what I'd like to do right now is open up the mic to the panelists and ask any of, whether Steve or Jim, whether or not, or Walter, if you have any questions specifically just about the overview of what the federal government is doing. And anybody from the audience is welcome to type in a question in your chat, and we'll take a few minutes to do this, and then I'll go over the Dell thing, and we will go right into Kelly's comments.
Yeah, this is Jim. Can you hear me?
Yeah, can you turn on your camera, please?
Oh, sure, if I can figure that out again. I got a question for Solly. The question is, this webinar here is about using technology to get the data, and I'm wondering why EPA, in all of its studies to date, has not used technology to get real data rather than relying on some really poor data, various sources with not good quality control, when you had an opportunity to actually use some tracking devices or technologies that could really get actual shipment data, why you have not chosen to use those as yet? Thank you.
Okay, I mean, that's a fair question. When we first say EPA, as earlier as Karen mentioned that the use of RFID for material bill of lading, we were involved in, ORD was also involved in that. Now, we started this a year ago, and we are actually looking into other ways of complementing the data we are collecting. So it's it's at early stage that where in our work in material flow analysis work. So I mean, but we will definitely be using if there is there is a chance to use other technologies. And let me ask my team members here if they have a.
Well, one of the things that are limiting us right now is also resources. So understand full well we have ambitious ideas to go down some of these pathways, but we have to limit our focus to what we have at hand and what we understand is desired of Washington operations. So we agree with you that more can be done, and we would like to have that opportunity.
Okay, thank you. Jim, any follow-up, or Steve or Walter?
Well, this is Walter here. Let me turn on my webcam. Also, a question for Sully. It sounds like your scope is pretty broad in terms of used electronics. How much are you looking at the reuse market and the market for refurbished devices, particularly mobile devices like smartphones and tablets?
Oh, okay. Again, that's a very good question. Right now, the first stage of the work that we are looking is mainly it does not really include the handheld devices because of the available data, even from the states. Many of the Midwestern states do not have handheld devices in their covered electronic recycling program. So, and we found this as a big missing data, and that's actually with this, the students that we just joined us is looking into, how can we incorporate this information and where can we get this data? So it's there is a lot increasing volume of cell phones and handheld devices that are not the data is not available in the state programs.
Okay. What I was going to add to this is one of the challenges that we had with this particular effort is really the lack of available data, and in addition to that, of course, the quality of the data. So the reason we went with this, we call it the cluster states or the region 5 state, is to at least have as much data as possible, as uniform as data as possible, with certain quality, with a specific area, and then start from there, use it as a model for perhaps for the whole U.S. But it's still finding the data with the quality that is needed for an EPA type of effort or report without any bias, if you will. It's a big challenge and still is a challenge for us. And one of the things that we did actually, maybe Karen could could comment on that, but one of the things that we did reach to our Washington colleagues is if there are any available data, and the question, the answer was similar to our conclusion that the data is not out there.
Okay, hold on. John wants to add something to.
Yeah, one feature that we clearly ran into early on was this information or the lack thereof. The problem that we faced was and still is the controls that the Office of Management Budget has over survey efforts on the part of the federal government. We are actively planning to go after a survey permission from OMB just to be able to fill in specific areas the lack of information. We see no other way to actually accomplish that.
Yeah, this is Karen, and I just want to expand on that a little bit. The ICR is what we were just hearing about. That's where we have to. The federal government is not allowed to go to more than 9 people and ask for information. So you can understand that 9 people isn't going to give us as much information as we need. So what in order to go further than 9 people, we have to go to OMB and make a case that says we need this information because of X, Y, and Z. And it's not an automatic. OMB does not just check the box and say, okay, you can have it. They are very careful to not bother you guys, basically, and give us the okay to go out and ask questions of you all. So it's not an easy thing to do. That's all I wanted to say. So consequently, we tend to look for publicly available data, which is what ORD is really talking about. So if there's publicly informational data available on cell phones and handhelds and that kind of stuff, we would be happy to use that kind of information.
Okay, thank you all. I do have a question from the audience, and I don't know if we want to get into this too much now, but I'll ask the question since we have a minute, and then after this I will just give a little overview of Dell's program. Excuse me. This is from Rosalind Scott, and she asked, will there be funding for pilots, for pilot programs?
I actually
answer. Yeah, please turn on your video, please, when you answer. Thank you.
The answer in part is that pilots can be considered, but we do not have funding under the current budget constraints that we have right now. So we would entertain ideas of pilots, and we would have to internally make a very strong case to go forward should one of the pilots excite us in the direction that we believe is the direction of the overall project.
Okay. Karen, did you have a comment? Thank you.
Yeah, and I was just going to say that there may be opportunity if there's a viable type of program that needs a pilot, maybe have a part or different parts of the federal government maybe pilot something, but that would be only if those parts of the federal government are excited about the thing at the project, and if it's something they feel is viable and workable within how they handle the materials. So that is certainly an option.
All right. Well, I think we'll be talking a little bit more later about maybe pilots being a good idea for a next step. So I'd just like to take a couple minutes to talk about Dell's program since Beth was not able to join us. Most of you probably know that Dell has a large electronics take-back program with the Goodwill organization, and they have over 2,000 collection sites around the country where people like you and me can go drop off our electronics. And those collection centers funnel their material to over 100 consolidation centers. And Dell in order to really have quality control over this and make sure that everything that goes to these collection centers winds up at the consolidation centers, and everything that goes to the consolidation centers winds up at approved Dell recycling vendors, they have a lot of boots on the ground and spend a tremendous amount of time and money trying to maintain the quality control in that program. So, you know, that's just one example, and it's a big example. Not many of the OEMs have that type of a program where there's so many other second or third parties involved. And so the reason I've had a lot of discussions with Beth about their program, and it's an excellent program, but as I said, it's very costly and there's risk. So, and the risk, just for maybe some of the RFID and AIDC people who are on the phone who aren't as familiar with electronics recycling, is that if sometimes material will come into a facility and somebody who might have a good idea and say, hey, you know, I think we're not getting paid anything for this material, and I know some guy who said that he would give me a few $100 for a truckload of this stuff. And the next thing they know, it's going someplace that has not been qualified. They don't know where it's going after it gets to that place. And all of a sudden, it's very easy for things to go sideways. So that program, and I'm sure a lot of the other OEM programs where in all the states that have producer responsibility laws could probably benefit from using advanced technology. And you know, it's a much longer discussion of whether that happens at the manufacturing level, where some type of tracking mechanism is put into the electronics that we buy, or some kind of a scanning thing that would tell us where we should be recycling them, and so on and so forth. So there's all kinds of options. But right now, I will stop the question and answer here. We'll have more time at the end. And I will turn over to Kelly Keogh from Green Eye Partners, who I said earlier, her company is in the trenches going into electronics recycling operations and making sure that their material is flowing to places in accordance with the electronics recycling standards that they're certified to. So, Kelly?
And hi, hope you're all well. So what Lauren said is partially correct about what we do. It's always a little confusing about what we do, but we do several things as a consulting company. We prepare recyclers for two of the certification standards here that we use in the Americas, and they're also international. We train recyclers on setting up businesses, managing IT assets, doing auditing, environmental health and safety issues within the industry. And then the third thing we do, which is what we founded our business on, is we do the downstream due diligence for the recycling community. So we will follow their material to a smelter, to a glass processing facility, to a battery recycler, to audit those facilities to the environmental health and safety criteria that a recycler puts forth for us to do that with. So that could be either for the standards, or maybe they're meeting Dell's requirements or Samsung's requirements. So we have our fingers in lots of parts of the pie, but it's really about the downstream and the due diligence of the recyclers and their material. So the reason Lauren invited me to come talk to you guys today is because we really see the kind of down and dirty, on the ground issues that the recyclers have. All of the people in my company come from the recycling industry. I've been working in it since 1997. My business partner, Nicole, and her husband's, she actually grew up in the electronics recycling industry. Her parents owned a large electronics recycler. So we really know what happens when paperwork's misplaced, or when you can't find downstreams, or how things like Lauren just explained happen, where you have somebody on the ground that says, you know, we're really not making any money on this material, and this guy came up the other day with a truck, and he told me that if I filled up the truck, he would give us X amount of dollars. So We also see that. I mean, I am sometimes at a recycler and I'll be auditing, and the audit will get interrupted because a man will drive up in a big truck, and it's a U-Haul rent-a-truck, and he'll say, I'll take all those printers and I'll give you this much money for them. That happens a lot while we're on site. But we also, because we're in an industry, we get the phone calls from people that are looking for material. I get them a lot, just because they assume that we're recyclers and not consultants. And I get engaged sometimes in little conversations with those people about where the materials, mostly for the fun of it, and because I'm trying to figure out where that stuff ends up. So there are a lot of complexities that make it really challenging for the recyclers themselves to track material. We also audit internationally, so it's in the U.S. that we see the most difficult issues regarding tracking, at least for the recyclers that we visit, because internationally, typically the material is managed as hazardous waste, and they're required by their governments via their permits or the regulations to track the material. So when I talk about internationally, I'm talking about OECD countries, a few non-OECD countries, but in Latin America, Asia, Europe, Canada, obviously, we see material being tracked to a level that we don't typically do in the U.S. because there's not a regulatory framework in which it's required. We also see the more challenging things being that the smaller recyclers themselves often use intermediaries. So they're not going directly to the next market on their own. They might be sending, batteries are an excellent example. They might have 4 or 5, maybe 6 chemistries of batteries. Those will go to one battery recycler, and maybe that battery recycler only handles the lead acid batteries and then sends the NiCads, the lithium ions, the alkalins. Those all go somewhere else, maybe to 3 or 4 different facilities. Maybe some of those are in South Korea, some are in Canada, some are in Mexico. So tracking batteries in particular is one of the more difficult tasks for the recyclers. So typically what we see is the recyclers are able to track the material to the next tier, and sometimes they're able to get at least a flow chart of where it goes to the tier past that, but they don't actually usually get asked for bill of ladings or proof of that for a couple of reasons. Some of them are required to do some of that work because of the standards they commit to, or they have contracts with OEMs, say Samsung or Dell, that require that they track it to the next level. One of the challenges for them is that the next level doesn't care. So say they send all their batteries to one big battery recycler, and that battery recycler sends them out to 5 or 6 different companies, the chemistries that they don't handle there on site. That battery recycler that maybe handles lead acid batteries and then ships the other 5 chemistries off to other smelters will tell you that maybe 5% of the material they receive comes from the electronics industry. So it's hard to get them to have any incentive to actually manage their downstream flows and update their electronics recyclers on where that material is going. They have no incentive. It's not a big market for them. They've been patient and put up with the requests over the last 8 or 9 years pretty well, but on the whole, it's very difficult to track your box of lithium-ion batteries that goes to recycler A, who handles lead acid, and then goes to another smelter that actually handles the lithium-ion batteries. As well, that smelter will tell you the material that they get from the electronics industry is so minimal, they don't even actually want to allow you to come audit sometimes, because it's more work for them to have an auditor on site. It takes up their time, and it would make sense for them if it were a big client and they were giving them a lot of material. So the bigger challenges are not maybe just the recycler level and the next tier down, but further on and tracking that material, as I'm sure you guys have experienced in your work that you're doing for the folks who just presented. The other thing is that it's not, how do I say this, especially now with the metals markets having gone down so much, the value of metals gone down so much, it's a very trying time for the industry, and they're not getting the returns on the metals that they were getting a year and a half ago, and I would say that I hope I'm not reaching a funny number just out of the sky here, but I'd say they're about 30% down on their metals prices. So to have anything that asks them to increase their administrative costs, it's very expensive to track material. And anyone that has any of the big contracts with Dell or Samsung will tell you it's an expensive endeavor to meet their requirements. While the requirements are wonderful, and I'm so proud of what they've done, the recyclers will tell you that sometimes they have to hire another person just to help them track that material. Like Lauren said, it's extremely expensive, not just for the recycler, but Dell's program for Dell itself as well. The other thing that happens is, and I talked about this a little bit, is say a recycler is sending material to one facility and then they change their downstreams. If a recycler is certified, they have an obligation to keep their material flow chart to final destination up to date and accurate. But oftentimes they're not going to even check that until they're ready to prepare for their annual audits. And at that time they'll try to figure out where their material is going and often find out that it's been going somewhere differently than they thought. But now they're preparing for an audit, so they have to scramble and get that paperwork together. The other thing is that the auditors themselves aren't typically from our industry, so don't even notice if there's a downstream that doesn't make sense. Whereas if we go in, we'll notice and we'll say, you know, we know this smelter's closed, or we know that this furnace isn't operating anymore, so you've still got them listed as a downstream, and we know that that's not actually where your material is going. You're going to have to take some time to figure out where that's going. So that challenge, metals markets needing administrative time to manage the material, to find out where it's going, dealing with intermediaries or final destinations that don't really have an incentive to produce the paperwork that people want them to have. I think those are kind of the biggest issues. One of the things that we often suggest to companies, and Lauren, I'm sure you have too, is for them having the certification requirements and the tracking requirements loaded on top of trying to run a business has been challenging. It's expensive. It takes resources that at this point, especially in this last year and a half, they don't really have. And what we try to help them to see is that it can be a revenue enhancer. It can be a way to get the larger contracts, to sell your services as well as your possibility to go above and beyond maybe other recyclers. The problem is, and you guys alluded to it a little bit, is there are a lot of recyclers that are under the radar. They're not certified. They're not part of a state program. And they're the ones that have the U-Haul trucks, and they go around from one recycler to the next, and they load them up, and then they sell them wherever they're going to sell them. So there's the formal recycling market, and then there's the informal recycling market. And while we can talk a lot about tracking mechanisms for the formal market, the informal market will continue to make it difficult for the formal market to be able to afford the things that we're asking of them because the other ones are undercutting them. So I just bring that to the table for discussion. And that's kind of my presentation for you guys. Open to questions.
Thank you very much, Kelly. That was a reality check on really the issues that we're talking about here, for sure. And I'm excited that Chuck Evanhoe is coming up next, but I am because I believe that he will be able to explain and give some examples, and also Tom King, about how certain types of tracking technology can actually take so much of the work out, and really. It might seem like, well, gee, now we might be looking at another expense, but if you do the complete return on investment, it might be something that is actually going to save a lot of money at the end of the day. So, yeah, so we'll figure that out. But do we have any questions from any of the panelists?
Yes.
Okay, that sounds like Jim. You want to turn on your camera?
Sure. So Kelly's raised a real gorilla in the closet question, and it has to do with the fact that enterprises may want to have this type of tracking, and manufacturers may want to have this type of tracking. Ideally, they would want that, but who, especially in this climate and this market, is going to pay for it? Are they willing to pay for it? Because the recyclers are squeezed and squeezed and squeezed, and they have no extra margins at the moment to provide the proper due diligence that this industry needs. If, as we all believe, that this due diligence is important, then are the manufacturers going to step up? Are the enterprise companies going to step up and say, yes, we want to have technological tracking, and we are going to require it, and we're going to pay for it. So I know Beth isn't on. Unfortunately, maybe Walter can turn his hat around and answer a little bit of this, but I think the manufacturers have something to say here as well as large enterprise companies. Thank you.
Yeah, hi, it's Walter. Yeah, I think it depends on what products we're talking about. If you know, if we're talking about you know, the used smartphone that that gets sold back to AT&T and they refurbish it, I don't know if we need to track that. But we also there's certainly materials and products that our members at the Consumer Technology Association certainly do track. You know, several years ago when the EPEAT requirements kicked in for computer devices, all of a sudden there was tracking 3 levels down for companies like Dell and HP and others that were getting their products registered under EPEAT. So I think you know, as has been mentioned, I think we do have a lot of companies that are really hoping to know more about what's going on downstream, at least for some products.
Okay, this is Lauren. I just wanted to explain, thank you for that, Walter. I just wanted to explain for some of the AIDC companies that are participating that EPEAT is the Electronic Product Environmental Assessment Tool, and you can find information about it at epeat.net, EPEAT, and basically it's kind of like the Energy Star logo for energy efficient appliances. It's a total environmental certification for electronic products. So that's what Walter was referring to. So
yeah, thanks, Lauren. Sorry to get mixed up.
No problem. We all get together and just start talking in alphabet. Are there any questions from the audience? Let's see. Let's see any right now. So why don't we move on to Chuck Evanhoe, and Jorge, if you can put Chuck's presentation up for him. Thank you.
Good afternoon or good morning, everybody. I appreciate you all taking your time. My name is Chuck Evanhoe. I'm the chairman of the board of directors for AIM Inc. And I'm also the chair of ADC1, which is the U.S. Technical Advisors Group for the U.S. to the ISO committee JTC1 SC31, which is about barcode and RFID standards. Next slide, please. So who is AIM? AIM is the Global Association for Automatic Identification and Mobility. We've been around for 40 years and originally started as the Auto ID Manufacturers Association. But roughly about 10 years ago, we moved into the whole stakeholder supply chain for AIDC, all the way from the manufacturer all the way down to the end users. We currently have over 700 member companies around the globe, and we're really all about helping stakeholders promote and utilize automatic identification, data collection, and mobile solutions for situations very much like the e-waste topic that we're discussing today. Next slide, please. So we do that by connecting the global community. AIM is the leader in standards development, especially technical standards. If you look at almost all of the barcode standards that have been developed in the world, they've come out of AIM. AIM is also the leading proponent for education and advocacy about automatic identification and data capture. Our goal is to help business process improvements by utilizing AIDC in all verticals. And we do that by facilitating a collective voice on regulatory and policy issues, not just in the U.S., but worldwide. And one of our strengths is drawing from the industry and the industry experts, and then that information across the world and promoting it so that what we may learn here in the U.S. we can facilitate into China, perhaps helping them with e-waste issues as well. Next slide, please. So our goal is to facilitate this effective AIDC adoption. We have a number of subgroups within the AIM community. RAIN is the Passive UHF RFID Alliance. We also have our RFID Experts Group, Healthcare Committee, Internet of Things Committee, as well as being the liaison to various standards committees internationally, both for barcode and RFID, as well as the Internet of Things. As well, next slide, please.
Chuck, excuse me, could you just very briefly define what the Internet of Things is?
Well,
very briefly.
I could try a brief. So the Internet of Things is using sensors and machine-to-machine communication, as well as cyber-physical systems, to communicate good data, or data, we'll talk about good later, but communicate data so that autonomous action can occur. That is really where AIM is the first meter of the Internet of Things. If you look at barcodes and RFID tags and transponders, those really start Internet of Things as kind of the touch point out in the real world. There are other sensors as well that do that and feed the Internet of Things, but people tend to forget about RFID tags and barcodes and how many of them are out there that would start this Internet of Things chain. And the best example of utilizing AIDC for Internet of Things is the example everybody uses about the smart refrigerator. Well, you go to the store and you get a carton of milk, and on the carton of milk is your barcode or maybe an RFID tag, because now we're going to what's known as item level marking, and that's appropriate to the e-waste discussion. You go put it in your smart refrigerator, and as you use it up, it knows by weight, because you've got a sensor in your refrigerator, it knows by weight how much you've drank out of that milk carton, because it senses it going in and out of your refrigerator, and eventually it goes, oh, you're out. I need to place an order for you to be resupplied. Oh, but I've just looked at your calendar and you're going to be gone for the next 2 weeks, so I won't do the order for 2 weeks. And oh, but then I've had a recall because this batch of milk had listeria in it. So, you know, now I put a big warning sign on your emails and your phone or whatever, and notify the FDA that your refrigerator is biohazard now. So that is the if you will, the good story. But Internet of Things is used everywhere already for, if you will, remote sense and activity. That answer your question?
Yes, that was great. Thank you.
I also happen to be the chair of the U.S. Technical Committee on the Internet of Things. So I get this a lot. In fact, I'm headed to Shanghai on behalf of the U.S. next week to work on some more Internet of Things standards. So in that discussion, what you heard me talk about was the use of automatic identification. I've talked about some of the things about the supply chain, but it really is about reducing a lot of error and helping accountability. You've got a lot of man hours tied up with data entry, and I've got a good example a little bit later in my presentation about what man hours and data entry have to do with one another and how bad it can get. By automating that, we just reduce the time spent by huge amounts. But we create the capabilities to identify the things. And I just talked about that carton of milk. We can get its pedigree all the way back to the cow with automatic identification technologies. And so in this e-waste discussion, what we're talking about is enabling going from the supply level, from the manufacturer level, all the way through the supply chain until final disposal or reuse worldwide. Next slide, please. So you guys go, what is automatic identification technologies or automatic identification data capture? What does that look like? Well, You all know about barcodes, both the linear 1D and two-dimensional. On your boarding pass, on your airline ticket, on that carton of milk I was talking about. Those are very much everyday things that we're all used to seeing. Biometrics is another type of automatic identification. Obviously, I use my finger to log into my PC these days. Love it better than typing in a very strong, complex password. I've done it one time, I register my finger, and then it knows who I am from now on. From the old days, and on the back of your credit cards until they all get replaced by chips, is the magnetic stripe. And that goes back almost longer than AIM does. OCR is another very important type. In the old days, if you will, old being more than 10 years ago, optical character recognition was used in a lot of computer applications. Today, the most recognized one is on your passport. And AIM is very active in making sure those standards for optical character recognition, the optical character quality, are part of that, so that all that security features that are behind your passport, with all the flex and the pretty pictures, don't impede the ability for your passport to be recognized and for you to be able to use your passport worldwide. Obviously, smart cards, I just talked about the chip in your credit card, is another type of automatic identification technology. And then, of course, one of the key topics we're going to talk about today is RFID, both passive and active. So passive is all about essentially dormant tag or a chip that gets activated by an external source, or an RFID reader in most cases is what you'd call it. And there's a lot of physics involved, but let's just say it creates energy in the chip, and then we call it backscatter, and it gives information back to the reader. Active is different in that it has a battery with it, and it is the transmitter, and a receiver is waiting to hear it. Now, there's some other variations of the two of them. We talk about listen before talk, talk before listen, and some other things like that. But those are really the two keys, passive and active. Another variant of RF technologies in the auto ID space is real-time locating systems. So we're not necessarily talking about GPS type systems, but we may be. But it's really about, for example, a mesh. You've heard a lot about Zigbee. So Zigbee creates a mesh, and using some timing between sensors and readers, both passive or active type technologies, you can figure out where something is. Other types of AIDC that you might not think about would also be your voice and your touch and some of those other technologies. Next slide, please. So I put together a little slide so people can go, oh yeah, I know what you're talking about. And the one that wasn't on the previous page is contact memory buttons. In fact, Lauren asked me about that the other day. Before we had high capability either RFID tags or 2D barcodes that could contain a lot of data, you would encode data in a contact memory button, and it's really kind of a precursor, if you will, to simplify it, an RFID type tag. So by getting in close proximity, you would touch the reader to it and exchange information. Now, these are still in use today in a lot of security systems. You see the guy walking around and touching buttons in a building in some places. So I still see it active today. Okay. Next page, please. So, the one thing I wanted to say is that Auto ID is great, but it's not magic. It doesn't work out of the box. So what have we done about helping the industry, in this particular case, e-waste, know what to do with AIDC? Several years ago, we created an international implementation guideline. So it's not a law or a regulation, but it is best practices for implementing RFID, radio frequency identification, so that you can track, for tracking stuff in the e-waste cycle. So it's all about how RFID can serve as a significant enabler of recycling of various products, but especially appliances and electronics. and at the same time recognizing that the recycling streams are challenged, that the RFID tag itself is something that needs to be considered, as well as the material that it's being attached to, whether it's glass or steel or aluminum or any of those other kind of products. So in this standard, if you'll go to the next page, we're looking to help you all use RFID to improve the environment, to comply with laws and regulations, and we did it as thought leaders and how we've identified the use of RFID to execute the requirements in the most efficient fashion. Now, that's not to eliminate barcodes. Barcodes have a very important place in the chain because sometimes RFID just isn't practical. As I said, this technologies, none of them are magic. They have to be implemented at the right place effectively. And if you go back to the one slide I had about from the top to bottom, from barcodes down to RTLS, that kind of is the cost. If you go one more back, I'm sorry about this, I was going to say it then. Goes down the cost chain, if you will. Barcodes are very inexpensive. Biometric readers are a little more expensive, but they're built in. But when you get down to RFID and RTLS, those become the more expensive technologies. Sorry, I meant to mention it back then. George, if you can catch back up with me. So, and what we've done is we have looked at, as thought leaders in RFID, we talked about, I heard the EPA, Karen, talk about the RFID initiative that they have undertaken. And this was done about the same time, and in fact, EPC Global is a stakeholder in AIM. But we took those best practices and have turned them into this technical report that is the implementation guidelines. So to do this, we look at tracking waste with RFID, and how we do that is looking at the laws and regulations throughout the world and working with those that are responsible for the process and the cycle. And we took into account input from, for example, the WEEE, which is the Waste Electrical and Electronic Equipment Directive in the EU, as well as the ELV in the EU. And the Japanese had a strong voice in this technical report, and they, in fact, significant parts of it are being implemented to track waste, electronics waste in Japan. And they're looking at HERL as well as the EPRP in Korea. So all these laws require precisely knowing where in the recycle stream things enter and who should be bearing the cost of end of life or recycling. So that's something that we encourage the U.S. to look at. As again, AIM as a facilitator looks at what the best practices are worldwide and try and promote them in the various countries. Next slide, please. So how does it apply? Did I duplicate a slide? No, I didn't. I'm sorry. So RFID tagging is really to help you identify either that there is an item or what kind of an item it is. So, for example, if an individual item is tagged, and again, I say tag or RFID tag, but a barcode may work as well, you can identify what that item is because we're talking about item level tagging at that point in time. If you then go put it in, let's say, a Gaylord, and you tag the Gaylord, and you can associate the kind of items that are in the Gaylord, then you only need to track the Gaylord, and then you know what's in it, and then it's helping you in the whole stream, saying all this Gaylord is the same kind of component. I don't have to worry about some other kind of manual separation down the supply chain. So the greatest problem is the consumer streams. You know, whether it's corrugated or newsprint, or it's plastic or steel or aluminum or other those things, and how do you separate those? And again, automatic identification is not magic. It's going to end up being done manually or with very expensive sensors. So we're very pragmatic, unfortunately. You know, RFID can help you in a lot of ways, but it's not every way. Next, please.
Jeff?
Yes.
Can you explain, though, what the difference between barcode and RFID is, and what the benefit of RFID is in terms of being able to capture so much information without line of sight and so forth?
So, yes, and I should have done that earlier. Thank you, Lauren.
Yep.
So a barcode is very simple. It takes, if you will, line of sight and proximity to read a barcode. As you know, going through the grocery store checkout counter, scanning that same carton of milk over and over until you get it to read. But it is very inexpensive, and there are good standards and very good readers, and they're not very expensive to implement barcode reading. However, RFID doesn't necessarily require line of sight. It's kind of an electronic barcode. And these days, the RFID tags have much greater memory capability than they did even 5 years ago. And you can store currently megabits of information about that product or other information so that it could be read by an RFID tag or an RFID reader. And again, not necessarily line of sight. However, RFID being radio waves, sometimes obviously the metals or the liquids that are around it will affect readability. So, as I said, it's not magic. It can help in a lot of cases.
So you can, so with a barcode, you have to, with the scanner, you have to go right up to that barcode and scan it.
Correct.
But with
Right.
RFID, depending upon the types of tags that you're using, you could literally walk up and down the aisles in a warehouse and just, pick up thousands of items at once and capture all that data, correct?
Theoretically, that's correct. But that's why I keep going back to it's not magic. It's all in how you implement it.
If it's all implemented properly, that's the big benefit. And the accuracy of the data as well. And I know on one of your slides you show some scribbly handwriting that shows what the problem is with manual data capture.
It is.
Okay.
So, and again, thank you very much. So, I've been in it so long, I get kind of used to just assuming things. So, kind of like that, we assume that recyclers will install the automated process that will help you simulate. That means identify individual things, either the containers or the items with RFID tags so that you can do something with them. And it goes much back to what Lauren was suggesting. Much like you could walk up and down the aisles of a warehouse and do an inventory or find out where things are, in general, you could be able to do that with an RFID tag in a recycling center as the item came through. So as the item is identified, you'd be able to get the information off that tag and get it routed to the correct recycle stream if you had implemented the process correctly. So for example, if you had an RFID tag on a PCB, a printed circuit board, that identified it as a printed circuit board, then as that item came through, you would know that that came in and that it needed special handling because maybe it had lead solder on it from 20 years ago versus lead-free these days. So, or that you might be able to identify a cathode ray tube versus an LED monitor. Those are the kind of things we're talking about implementing in the recycle stream. So, next slide. One of the questions that was asked is, why would we do this? If you look in the lower left quadrant, you see some scribbles. And that's where we've taken real samples of what somebody has written and just put it on the page for you. And we're going to challenge you to figure out what they really wanted to write. Is that a 1S? Is that a 15? Is that an LS? Is that an O or a G? I mean, an O or a 0? Is that a G or a 6? So you get the picture. So what we're talking about is implementing AIDC in the entire chain from manufacturer at the OEM level, through assembly, through work in process, all the way to the finished good, whether it's nested data or individual data, and you just have it on the end item, but then you're able to track it through your supply chain. It'll help all through the chain with, for example, service and warranty issues, tracking logistics. I mean, FedEx and UPS make their name by knowing where your package is and when it'll get delivered. And then in your operations, we talked about inventory, we talked about those kind of things. So whether it's a barcode or RFID, what you get is good data, and I heard that challenge a little bit earlier to the EPA about getting good data. So this way you get good data in your data pool to do something with downstream. So ideally it would start with the OEM and until it gets the end of life, whether it's the recycler or beyond. So those are the kind of things that we look at AIDC as how it should be applied in order to get the most benefit. Because if you just do it at the recycling point, then you really haven't gained the true benefit. And if there's benefit along the supply chain, more people will do it. Next slide. So one of the things we're suggesting to this group is that the key stakeholders here should get together and consider a pilot, like a PC recycling effort. I heard reference earlier to the Dell recycling with Goodwill, so something similar to that. We would suggest a small closed system so that you're not looking at lots of other inputs, i.e. one receiving center where it's a very simplistic process, and then using a combination of AID, so whether it's barcode and or RFID, to track those containers, and then progress it to associating the items to the container to a truck, getting some more identification, and then getting that information out to those people that can use it as that container or that item goes further down the supply chain. Once that's matured, you can expand it to other facilities and then look at moving the process up and downstream. We talk about upstream, much like I talked in the previous slide, to the logistics, the service, the warranty, the manufacturing process, those kind of things, and then downstream to the recycling process to enable autonomous sortation, which would be where I was going to draw the analogy to Internet of Things. If you can do things autonomously because there's an RFID tag or a barcode, then you've moved into the Internet of Things world with this technology and applying it to your particular vertical's issues. Next slide is questions.
Okay. I have Karen, you had a question. Do you want to get started, please?
Sure. We were wondering, I have a team of folks here listening in, and we were wondering, Chuck, if RFIDs are already used in some of those other countries that you mentioned, specifically for electronic waste, and if it is there any publicly information available that would tell us how it worked and maybe the cost of implementing such a program?
So I'm sure there is. Let me go and get that information and get it back out to you. Because we know that there have been a lot of efforts within the EU and within Japan in particular, I'm aware of. So we can reach out to the organizations, our chapters in those countries, and get you the data.
And would it be in English?
Well, it'll be pretty close to English.
All right. Good. Thank you.
So we'd be glad to take that on. Again, we're an industry group. We're here to help you all you all, depends on if you're in the South, implement our technologies. And what we can do to help you helps our stakeholders. So we'd be glad to do it.
Thank you.
I'll even write that one down.
Okay, let me see if we have any questions from the audience. I don't see any.
There are questions, Lauren. This is George.
Okay.
I'm going to ask Chuck, it's a two-part, go very quickly. It says, how high are the costs to implement a complete RFID track, and how soon do you think cell phones will be equipped with RFID readers?
All right. So let me take the last one first. It's easier. There are cell phones we have seen with RFID readers built in. There are also, and let me be clear, So there are lots of cell phones with NFC built in today. NFC is near field communication. It is a form of RFID. We have seen recently cell phones with what's known as passive UHF readers. So what most people would consider an RFID tag, we've seen those today. Now, they're not necessarily in mass market, but we've also seen lots and lots of what we call sleds, kind of like a Mophie pack for your phone. It slips on the phone and enables RFID reading. So we've seen sleds that work today as well. They've been around for several years, either Bluetooth connected or directly connected. So passive RFID readers, non-NFC, I would expect you could see those on the market in the next couple of years at the worst. So your first question was what? I was so busy answering the second one. George, help me out.
It was just high up the cost to implement a company.
Okay. So it depends on your implementation. Let's be pragmatic. A nice paper-based RFID tag, in other words, a label, is not very expensive in a significant quantity. The tags themselves are in the call it 5 to 10 cent range. Depends again on quantity. Worst case, 25 to 50 cents a piece if you're buying a very small quantity. The readers are not very expensive. If you get a handheld reader, you're looking, in the $1,000, $1,500, $2,500 range for one handheld device that reads RFID tags. But what you're talking about is probably more of an infrastructure where you have your portals manned and you have your software running and tracking and doing all of that with all the choke points monitored and software running and maintenance and lots of tags. As part of your business process, it can vary. We've seen implementations as low as, if you will, $50,000 for a very simplistic, simple implementation. But we've also seen them in the millions. And in fact, I think Tom King will be talking about their
That's what I was
implementation
just going to say, yeah.
which I happen to know about. So, being the AIM chair is my part-time job. My other part-time job is running a small systems integration company. So, did that help you, George? Did that answer your question?
Yes, thank you.
Great. Thank you. Well, Chuck, that was really informative. I appreciate it. And I think we better move. Our next speaker is Tom King, and he is with the U.S. Patent and Trade Office, who is just implementing an RFID system to track their IT assets. So I'm going to turn it over to you now, Tom. Thanks.
All right. Thank you very much. I'll just answer one of the questions that was tossed out there to Chuck. One of the things we did here at the USPTO, we're actually using the cell phones, but we also invested in one of the sleds, because one of the things we found out is that the cell phone is not quite as nice and rigid as maybe we would like it to be when it comes to scanning. So
okay.
we'll go ahead and jump into the presentation.
Thomas, a sled, is that like a scanner like you have on a Square card? It's like an extra thing that you add to your phone, right?
Yeah, actually, what it's a case that your phone fits in, so it actually does a couple of things. It protects your phone in case you drop it, and it enhances the ability of the phone to scan. Though the RFID technology that's out there for the sleds is mostly contact or near contact. So we actually chose, originally in the project, we were going to go with that as a solution, but we actually backed off from that later on. We just decided it wasn't worth the additional cost at this point.
Okay, thank you.
Mm-hmm. So we can go to the next slide, please. We just quickly, just the agenda here. I'll talk about the background of the project here at the PTO, some of the goals of what we're trying to accomplish through the RFID implementation. I know a couple questions about return on investment came up. We'll talk about the PTO process and what we came up with on our return on investment. And I'll get into some of the equipment we're using and even future enhancements. So some of those RFID is going to allow us to move, but they're not quite RFID related, so I'll just kind of touch on them quickly. So next slide. So briefly, the USPTO, we started our asset management program here back in the early 90s. Back in those days, the USPTO, when we first started doing our financial audits, and they were including assets into the process, one of the basic questions the auditors had for us is, For a purchase order of, let's say back in those days, 100 monitors, where are those 100 monitors today? And it was a question the PTO couldn't answer. So what we came up with was developed a system that was very labor intensive. It's an extremely manual process we still use today. And obviously, as with any system, the weakest link is always the reliance on human interaction. As you saw from the scribbly notes that Chuck was showing earlier, we don't necessarily have scribbly notes, but there are parts of our process where we do depend on a handwritten note. And a lot of times an S looks like a 5 and vice versa. And so we're moving towards RFID to help try to reduce some of those problems. The other things we're trying to accomplish is we have roughly 1,000 people total between our property custodians and our property accountability officers. And let me just explain the difference there. The PC, or property custodian, is the person who is responsible for, on a monthly basis, visually inspecting every asset that's under their purview. We try to keep it to somewhere between 150 to 200 assets per property custodian, but in some cases, like in our warehouse, or a person who is in charge of our maintenance activities for our desktop, he has over 10,000 assets that he's responsible for. And each property custodian has the next level up, which is their property accountability officer. As you can see on the last bullet there, we have roughly 112,000 assets, depending on what day you check the system, and they're worth about $173 million. So the PTO has a huge investment in its inventory and our ability to be able to track. Next slide, please. So back in June of 2012, and actually a little bit before that, the Department of Commerce, Patent and Trademark Office falls under the Department of Commerce, and they supply all of our inventory tags that all of the bureaus within the Commerce use, including NIST and Census. But one of the things that had been started at Commerce Department was this idea of implementing RFID. So unfortunately, because RFID back in the early 2000s wasn't quite as mature as it is today, that didn't go anywhere. So in 2012, we actually put together a budget initiative that was included in our FY 2014 budget that the President approved. So therefore, we were able to move on with the project. And what happened in the fall of 2014, we actually awarded a contract to a team, which I think we actually did a pretty good job of picking our partners. DTI, Digital Technologies Incorporated, out of Herndon, Virginia, and then Evanho was their partner. And the cool thing is DTI knows the PTO, its ins and outs. We're kind of be a little bit of a quirky agency, to say the least. And Evanho, because of their background in RFID technology and in working with the government sector, it turned out to be a very good team for us. We actually broke our project up in a couple of different parts. We did a site survey, bought the software, and then we're in the process now of pretty much installed all the software here on campus, or all the hardware. One of the things is we were so concerned about the cost of RFID that we actually set up the contract in such a way that after the site survey, which was performed, which was a firm fixed price task, if the PTO decided the cost was too much, we could just kill the contract at that point. Because quite frankly, there was so much unknown with RFID technology from our perspective as to how many readers we would need, how much it would actually take to get those readers up, the software, get all the tags on our equipment. We just said, look, let's go through the site survey. Let's find out in great detail what the cost is going to be. And if the cost is too much, we'll kill the project. And actually, the cost came in a little bit less than we expected. So obviously, we were very happy with that. Next slide, please. So some of the goals of our RFID project. First and foremost, we want to reduce the number of property accountability and property custodians we have involved. As I said earlier, we had over 1,000 people involved in the process, or roughly 1,000. One of the things to keep in mind is a lot of these folks are GS-15s or even SES level folks, so they're making a good amount of money. And also, the Patent and Trademark Office is a little unique in the federal sector in that we're a completely 100% fee-funded agency. So just like a private sector company, we only can spend what we make on revenue. So a lot of the folks that we have involved in our inventory process are patent examiners and trademark examiners. So those folks, instead of spending time generating revenue for the agency by looking at trademark or patent applications, in a lot of cases they're spending an inordinate amount of time and being involved in our inventory process. We're also trying to reduce the inventory cycle time. Today, we generate reports on the first of the month, and we spend the rest of the month trying to chase down those reports, making sure that the system is updated. And then probably most importantly of the three, but probably the most overlooked on our side, is increase the accuracy of the system. As I said earlier, the more people you have involved in the system, the more opportunity you have for mistakes. And while we have roughly 1,000 property custodians and PAOs involved, we also have several hundred other contractors who are involved at different stages of the system, be it assets as they arrive in the warehouse, when they're first tagged and inventoried, and to the end when assets go out of the warehouse and are surplus to either other agencies or to recyclers in some cases. Next slide.
I just popped up here because we're getting a little close, but I know you've got some really good information coming up, so I just wanted to give you a little heads up.
Okay, cool. So the next thing I want to head on is, you guys talked earlier about return on investment. Our total cost is approximately $3 million. That includes all the tags, inventorying all of our equipment, implementing all of the hardware and software, not only here on campus, but also at the PTO's satellite offices in Denver, Dallas, Detroit, and San Jose. So as you can see, we are anticipated about a $1.1 million savings per year. So in roughly a little over 2.5 or less than 3, depending on how you look at it, years, we will have a return on investment at the PTO. Down at the bottom, I kind of broke it up for you just in some quick numbers. PC is property custodian labor. Asset management labor is actually contract labor. And loss prevention, we anticipate that the majority of our quote-unquote losses today will disappear because we'll be able to track a little bit better. Next slide, please. So what we're using here at the PTO, we are using mostly fixed readers. We actually have them above the ceiling tiles on all the floors of all the buildings. We have lobby readers, which are flush mounted only because it's drywall, which can be a little bit problematic when it comes for the readers to read, especially from the heights that some of our ceilings are. And we have these in all of our buildings here on campus, our warehouse. So we have on campus 7 main buildings, 2 townhouses. Then there are also 3 other buildings that we have here close proximity to campus. And we have a warehouse down about 10 miles from the office. And as I mentioned earlier, we have satellite offices. We are also using mobile readers. I think it was Chuck mentioned or someone mentioned the ability to walk down through the store, a grocery store, and read all of the barcode labels. One of the things that we're using is because the majority of our assets do not move during the day or during the month, is these mobile readers will be used by our staff to walk down the hall literally a couple hours at the end of a month, read all the tags, upload them into our system and say, yes, those assets have been found. And in the future, our property custodians will only be worried about those few assets that we may not find using our RFID readers. Next slide. So here is a snapshot of the barcode. We are using passive technology currently. It does have a barcode on it because when the tag first comes into our warehouse, we actually physically scan the barcode into our system and associate it with there's a CD number, Commerce Department number that's required on all assets, as well as a serial number. We did and will at some point in the future have a active technology that we're using in our data center and our cabinets for our servers and also for our switches for our telephonic services. Next slide. So we did the next couple slides. We just show you kind of an overview of typical floors here and kind of some of the work that was done to determine where we need to place equipment, because our goals were to have the critical locations covered. So obviously we wanted maximum coverage and minimal amount of equipment. So if we flip to the next slide, you'll see one of 2 floors. And this is our typical first floor at the PTO. There's a big atrium opening, which is what you see at the top of the screen. All the green circles are basically reader points. So what happens is as an asset moves around campus or moves around on the floor, it will report back its location. Its ultimate final location will be then transmitted to our inventory system, and we will then reconcile the asset automatically versus having someone to sit there and fat finger or type in all of the information for its location. And if you flip over to the next one, that's just a typical floor in general. The first floor is obviously configured slightly different. As you can see, we have a lot of offices crammed into the office space here. So again, these are just critical read points. Our idea is you can't go down any particular location without us knowing you went down it. Ultimately, what we want to do is expand the number of readers so that each of those corridors would have readers at central points but obviously we don't have that at this point. We decided to start with the bare minimum and then move from there. Next slide, please. So some of our future enhancements, and the very first one, the real-time updates, actually RFID is going to go a long way towards making that happen. For example, we're going to start our property custodians today. A property custodian can have assets all over campus. We're actually going to be refining that and getting away from 800 plus property custodians. We'll have about 110 property custodians who will be with us in the future. On-demand reporting, that's also one of the things that RFID is going to allow us to be able to do, because today our system is more of a batch-related system. With RFID and the scanning that goes on, since the updates will be made real time, we'll be able to allow our users to run their property custodian report when they're ready to track it. The last one there, home use assets, I just put it on there to make a point. The Patent Office, of the 112,000 assets, roughly 35,000 of those assets are actually at employees' homes. Obviously, RFID technology at home doesn't help us because we don't send readers to people's homes to be able to read those assets. But when they come back into, when they're first delivered here to PTO and when they come back to be disposed of at the PTO, that's when the RFID technology would take over for us. And I believe the last slide is just question and answers. We'll move to the next one. Yep.
All right. All right, that was very close, and that was great, and it made it real looking at those floor plans and kind of getting an understanding of where you put the readers and so forth, so you know where things are going. So I think we have some questions from the panelists, and I'd like to, I think Solly had a question. And excuse me, let me regroup here. Before I go to Solly and Jim, if one of you has a question specifically for Tom, and you can ask it now, and if not, then we'll just open it up to other questions from the panelists. And again, the people in the audience, feel free to type in your questions. If we don't get to them by the end, they will all be answered. So it looks like Karen has a question for Tom.
I do. Thank you for this very informative presentation. It's interesting to see that these are actually being used. On your last slide, you mentioned at-home work. Is that tracking it through the home, I guess? How does that happen? Is that for telework folks?
It is, because we have 3,500 people who work full-time from home, so they never come into the office. And the RFID technology only tracks it, obviously, when it's here on campus. So when it's originally delivered, it's prepared, and then when it comes back in for other maintenance activities or whatever, when we actually track it at home, we actually use other software from the computer itself reporting back to us. So we don't really use RFID once it's at someone's home. For a lot of reasons. One, it's very expensive to provide readers for all those folks.
And when we're talking about this tracking program, does it include all of your computers, monitors, as well as cell phones and other printers and that kind of stuff that you all use?
Yes, we track all of our desktop equipment, so the monitors, the printers, the laptops. We pretty much use laptops here at the agency. We have some folks who still have desktops, all of our servers, all of our routers. We do track cell phones, but we're probably not going to track them with RFID, only given the size of the barcode and the size of the device. However, things like iPads and things like that, we will have RFID tags on them. So we track we track about 3,500 different types of equipment.
And has this program been installed and been working for a while, or is it fairly new?
Which piece? The asset management piece has been installed and working for 20 years or better now. We're actually in the middle of upgrading our inventory system. The RFID, all the hardware is installed, all the tags are in place, and we have started testing the readers, but we're not going to actually turn it on its full power until September.
Okay, thank you. That's the piece that I was interested in. Thank you.
Mm-hmm.
I have a question to check just how this technology can be used for the RFID for tracking for waste products, especially e-waste, because I can see how for high-value materials the cost could be justifiable, but in this case it's a waste material. And what kind of how do you envision this happening? That the tags are there at collection or from the manufacturing point, or and has every recycler and down the stream everybody has to have these readers? How do you envision that this to get good information out in the system?
So ideally, let's start at the end. All recyclers would have readers, and ideally everybody would put tags on at the beginning of the process, whether it's manufacture or assembly. But pragmatically, I think your start is in a closed facility at a container level, and that becomes a very manageable cost until such point all the tags have been implemented at the manufacturing level. So, for example, we are aware that Intel is beginning to build RFID into some of its chips, and so if you can use that already, then you can use those on an assembled board and an assembled PC and an assembled whatever. So if we can get more manufacturers to use it for their own benefit, for example, work in process or manufacturing or supply chain, then at the tail end in the recycling chain, they'll already be on there. Does that explain things?
Yeah. So John has a question here.
A question about the proximity issues relative to detection of the tagged item. Does the signal is it receivable even though you may have significant barriers or piles of material in front of you? How does that actually work, and what are the general limitations for detection there?
So it depends on the materials that are in the way. These are radio waves generally at roughly 900 megahertz, 860 to 960 megahertz. And so if you look at that, liquids will impede the signal, as well as direct contact with metal by the RFID tag, as well as having essentially metal around a tag will stop the signal from coming through as well. So generally things like loose newsprint or a cardboard box, not a problem. But if you're talking about like a whole bunch of tin cans around you, you've got a problem. Now, with unimpeded tag, if you will, one that's, you've set on a shelf or whatever, we've seen tag reads at easily 10 to 20 feet, easily up to 50 feet sometimes, reasonably. So again, it all depends on placement, tag type, and what's surrounding it. There is no one answer, unfortunately.
Okay. The one other follow-up question I have there, these are obviously powered in some way by a battery, I believe. What is the lifetime of the energy source associated with the RFID?
So there are two different types, as I talked about. Passive does not have a battery on it. Its power is given to it by the reader. It's energized by the radio waves, and then it does what's called backscatter and sends a signal back with data. The active tags do have batteries. We're seeing life depends on how often you have them what's called beacon, anywhere from a year to 5 years to 10 years. So depends on how often you ask it to talk.
If they got into an area where there would be RFID intercepts, would they then respond, obviously, to these intercepts that may or may not be part of your detection circuitry?
So in the current technology, which is known as 18063, the latest iteration is also known as EPC Gen 2 V2. There are security features built into tags as well as cryptography. So tags can be programmed to or not to talk. if you're not a recognized system, for example. Now, in general, that's not necessarily needed, and most tags will be what we would call open and readable.
Okay.
Okay, I think if the, we're going to have hopefully a lot more dialogue between the EPA and the AIDC organization. So, and I know that there's people in the audience that have a lot of questions, and unfortunately, this was really an introductory meeting, and it was kind of to take the lid off of this and open it up a little bit, and I've learned a lot. I hope a lot of other people have learned a lot. I had put these kickoff questions, hoping that we had a little bit more time for question and answer. I would suggest that maybe we should have another meeting after this that's maybe we dedicate a little bit more time with a break in the middle so that we can address everybody's questions a little bit more in depth, but all the questions will be answered. I just think some of the key things that we need to start thinking about here are these questions that I posed here. One is, should tracking of electronics be regulated by state or national law, or should or could voluntary standards organizations insert tracking requirements into their standards? And another one would be, how might a tracking pilot be conducted? We talked about that a little bit as well. And certainly next steps. And I think I will probably have to regroup with the EPA folks and come up and maybe address some of these questions and the next steps after this, because there obviously has been a tremendous amount of interest in this topic, and I think a lot of potential as well. I'm just going to quickly, Solly had submitted a question to me, and then I know Jim Puckett wanted to say something, and if we have any more, and then I just wanted to wrap up with one more slide. So I think it's 12:26, so we only have a few more minutes. Solly, a little bit off subject, but not really. He asked if recycling is cost effective. And, that's the $10 million question. A lot of you saw the New York Times article, and that person would say that in many cases it's not. But my question back is managing hazardous waste and conserving resources cost effective? Because often the question, is recycling cost effective, is asked, it refers to whether it makes sense to recycle non-hazardous materials, which are plentiful, like plastics, for example. But with e-waste, we're talking about proper management of hazardous components and conserving extremely limited resources such as rare earths. So it's a much more complex question when it comes to electronics than it comes to other materials in our solid waste stream. Jim, did you have a question that you wanted to ask before I go to the last slide? And you can pull up the last slide, please, Jorge. Thank you.
Sure. I do think we need another session because my question has to do with using this for enforcement. These systems are only as good as people want to be tracked and have intentions of being tracked. But as we know in this industry, a lot of things go sideways, and there's a lot of people that don't want to be tracked, and therein lies so much of the problem. So my questions that I would probably have to have a whole new session on would be, how can we use this for enforcement? And I think you were alluding to that, Lauren, with one of your last kickoffs there about requiring things, but also then we would have to have I wonder if there's a precedent somewhere in the world that there's a requirement not to tamper or disable tracking devices, because that would be key to any type of enforcement activity. And maybe Chuck knows about that, and he can answer that real quickly. Thank you.
Okay, Chuck, you want to hit that quick, and then I'll wrap up?
So the answer is I don't know, but I'll find out.
Okay.
I've already reached out to our chapters across the world. I sent an email while we were online, and we're starting to get people thinking about it now. I will check with them. Again, with RFID, it is a tag or a label. It can be removed, destroyed. So it's not the nirvana, but there are ways also to tell that something's been tampered or destroyed. So, and again, depends on cost and implementation and return on investment.
Okay. Thank you. So again, I just want to make sure that everybody knows that their questions will be answered. We'll probably post all the questions and answers because that's going to help to keep the dialogue going. I set up a new company page for Transparent Planet on LinkedIn. So I'd invite you all to go follow that and engage in it so that we can use that as a forum to keep this dialogue going and to plan on what the next steps will be. And please also feel free to contact me to get any questions answered about RFID or other AIDC applications and capabilities. And if you're in the AIDC business, you can also contact me to talk about ways that through forums like these and others that we can help to grow and expand the adaptation of RFID and AIDC. So, Karen, why don't you pop up on here so you can say goodbye with me? Is Karen still there?
Yeah.
There she is.
Yeah,
I really wanted to thank the EPA and Jorge and you guys for running the technology here. It was really nice to be able to see the speakers, and it was a huge help having you guys handle the webinar side of things, so thank you.
Well, thank you for doing this, and thank Jorge for running that because I couldn't do it. So thank you.
Okay, so thanks again, everybody. Have a wonderful day, and we will definitely be talking soon. Bye-bye.